The last type of stoichiometry problem we can do involves figuring out how much heat will come in or leave a reaction as it occurs. In this case, we've got 3.5 grams of methane gas being burned with oxygen, and we'd like to know how much energy is coming out of this combustion reaction. Okay, well, like we always do, we check to see if we have a balanced chemical equation, which we do, and then we're ready to get into our stoichiometry. So we'll start again with our 3.50 grams of methane, CH4. And just like as always, we get from grams to moles using molar mass. So 1 carbon with a mass of 12 and 4 hydrogens with a mass of 1 gives us 16 grams of CH4 to being equal to 1 mole of CH4. Now we're ready to use our mole-to-mole ratio, except the problem is we're actually looking for a mole-to-energy ratio. Well, we know in the balanced equation there's supposed to be a 1 here, so we can say for every 1 mole of CH4, we're going to release 802 kilojoules. And that would be sufficient for this problem, because when we go through and calculate out how much energy we release, we get 175 kilojoules of energy coming from this 3.5 grams of methane. So quite a bit of energy being released here. This is the last and final type of stoichiometry problem you can encounter during the course of this chapter. There may be variations on it. As always, you'll want to check to make sure you have balanced chemical equations. You may be exposed to situations where you have 2 masses of reactants, and so you'll have to do the limiting reactant in each case. But really, these are about the only variations and types of problems you'll see when it comes time to dealing with stoichiometry.